Hi friends, let's solve this question. If alpha is equals to limit of x tends to pi by 4, tan cube x minus tan x upon cos of x plus pi by 4 and beta equals to limit of x tends to 0, cos x raised to cot x are the roots of the equation ax square plus bx minus 4 equals to 0. So then the ordered pair a comma b is equals to. So we have to find the value of the coefficient x square, which is a, and the coefficient of x, which is b. Alpha and beta are the roots of this quadratic equation. So by solving these limits, we will get the value of alpha and beta. And once we get the value of alpha and beta, we will generate the quadratic polynomial which has a root alpha and beta, that is nothing but x minus alpha into x minus beta. And then by some simplifying, we will get the value, and simplifying and comparing with the equation ax square plus bx minus 4 equals to 0, we will get the value of a and b. So that is the idea. So what you have to do, we have to just we have to solve this limits question to get the value of alpha and beta. So let's start with alpha first. So we have alpha is equals to limit of x tends to pi by 4, and in the numerator it's a tan cube x minus tan x. So we have to simplify this function before calculating limits. So let's take tan x common. So we are left with tan square x minus 1 upon, it's a cos x plus pi by 4. So we can use the formula of cos of a plus b, which is cos a cos b minus sin a sin b. So now we have limit of x tends to pi by 4, and we know that tan x is a well defined function at pi by 4, which is nothing but 1. So we will separate that limit. So we have limit of x tends to pi by 4. Then for the tan square x minus 1, we have to simplify this. As the denominator contains cos and sin function, we will convert the numerator tan square x minus 1 in the terms of cos and sin. So then we have sin square x upon cos square x minus 1 upon, then it's a cos x, cos pi by 4 is going to be 1 by square root of 2 minus sin x, again sin of pi by 4 is a 1 upon square root of 2, so I'll write it as a common 1 upon square root of 2. So then what we have extra, we have limit of x tends to pi by 4, then we have tan x function, okay, which we are separating the limit for with that function because it's a well defined. Tan of pi by 4 is going to be 1. So now what we are left with, we are left with a limit of x tends to pi by 4, then by cross multiplying the numerator, so we get sin square x minus cos square x upon, we'll take this square root of 2 in the numerator. So this is square root of 2. Then in the denominator we have cos x minus sin x. Then this value turns out to be 1. Okay. So now let's see what we get. And here there is a 1 upon cos square x. Okay. The denominator. Yeah. So now here again we get a square root which is common. The square root of 2. That's the limit of x tends to pi by 4. Then we can factorize the numerator by using the formula of a square minus b square. So we have sin x minus cos x into sin x plus cos x upon cos x minus sin x. The denominator we have cos x minus sin x. Okay, and we have into 1 upon cos square x. Again at pi by 4, cos x is a well defined function, so we can separate the limit and we can substitute the value x equals to pi by 4 in the cos x, and then it's easy to see that cos square x, so cos cos of pi by 4, it's 1 by square root of 2, then doing squaring, so it's going to give 1 by 2. So now this is equals to, we have square root of 2, and here this cos x minus sin x, and in the numerator cos x minus sin x gets cancelled, and we have minus 1 in the numerator then. So we have square root of 2 into minus 1, and then we know that at x equals to pi by 4, sin x plus cos x is a well-defined function. So it's a sine of pi by 4 plus cos of pi by 4. So it's a 1 upon square root of 2 plus 1 upon square root of 2. So it's going to give us 2 upon square root of 2 into, and this 1 upon 1 by 2, it's going to be 2. So now this gives us value minus 4. So this is how we get the value of alpha. So now let's calculate the value of beta. So what we have beta equals to, limit of x tends to 0 cos x raised to cot x. So now this is equals to limit of, so as we have a variable raised to variable function, so we can take the help of logarithm to simplify this. So let's take logarithm on both the side. So what we are going to have, so we have log of beta equals to limit of x tends to 0 log of cos x raised to cot x. Actually, it was log of limit, but it became limit of log because log x is a continuous function. So now this is equals to, we get limit of x tends to 0. It's going to be cos x upon sin x. Basically, by using logarithmic property, cot x is coming ahead. It's a cot x into log of cos x. Now again, if we look at our function, we have a cos x and x tends to 0. Cos x is well defined at 0. So cos 0 is 1. It's in multiplication, so we can separate the limit. So we have limit of x tends to 0 log of cos x upon sin x, and then into limit of x tends to 0 cos x, so which is nothing but cos 0, which is 1. So now when we substitute x equals to 0, so cos 0 becomes 1, log of 1 becomes 0, and denominator sin 0 becomes 0. So it's a 0 by 0 form now. So we can apply L'Hopital's rule. So we have limit of x tends to 0. So what's the derivative of the numerator? So log x derivative is, so log of cos x derivative is going to be 1 upon cos x. Then by chain rule, cos x derivative is going to be minus sin x upon sin x derivative is cos x. So now we can see that the limit is well defined because denominator is a cos square x and cos 0 is 1, and the numerator sin 0 is going to be 0. So 0 by 1 is going to be 0. So the beta value turns out to be 0. Okay, it's a not beta, it's a log beta. Log beta value turns out to be 0. So what is a beta value? What is an exponential form? It's going to be e raised to 0. And what is e raised to 0? It's going to be 1. So the beta value is 1. So alpha and beta are the roots of the equation ax square plus bx minus 4 equals to 0, and this is a quadratic equation, so it has only two roots, which is nothing but alpha and beta. So what is a polynomial if alpha and beta? So what is a polynomial? What is a quadratic polynomial which has a root alpha and beta, which is x minus alpha into x minus beta? So what we have, it's going to be x minus of minus 4, so it's x plus 4 into x minus 1. This is equals to 0. This is the quadratic equation which has a root alpha and beta. So then we get x square minus x, then plus 4x, so it's going to be plus 3x minus 4. This is equals to 0. So now comparing this quadratic equation with the given quadratic equation in the question, so what we get by comparison, the value of a is 1 and the value of b, it's a small b, sorry, and the value of b is 3. So option A is correct. Let's see the question. Okay, so option A is correct. Yeah, thank you.